Hello all. So in this session we'll be discussing about second laboratory program of operating system. So we know that in second program there are mainly four sub-programs. So it entirely depends upon the scheduling algorithm. So under that the first program is FCFS CPU scheduling algorithm. So we know that as a regular practice we'll start writing our C program with the help of header file. That is hash include stdio.h, so it is used for scanf and printf statement. So we know that the actual execution of the C program starts from the main function, right? So execution of the program usually begins or starts from here. So next we have variable declaration. So we are using data type called integer data type for burst time, waiting time, turnaround time, and we are using two more variables, that is I and n. So I is used for loop counters and n defines the number of processes. So here I am taking single dimensional array of size 20, right? So next we are taking one more data type called float in order to calculate average waiting time and average turnaround time. So this is about variable declaration, right? So next we are entering the number of processes, right? So in order to read the number of process we are using the for loop, right? So where user inputs how many process there are, right? So next we have reading burst time for each process, right? So where user will input or give the input of burst time for each and every process, right? So here we are representing burst time with the keyword called as bt. So bt indicates it's a burst time. So loop runs n time, right? So here n means the number of times the user has given the number of processes, right? So burst time for each process p1 p0 p1 and p2, so which will be stored in burst time variable, right? So next we are initializing the first process. So here as you can see we are initializing the first process, right? Usually first process is p0, right? So first process usually will be having zero waiting time. So usually waiting time starts from the second process, that is p1 process. Okay, so next its turnaround time is equal to its burst time, right? So next we'll initialize averages with the first process values. So after this what we'll do is we'll calculate waiting time and turnaround time for each and every process using this formulas, right? So waiting time formula says that it is the sum of waiting time of I minus 1 process and burst time of I minus 1 process. So if you are calculating the burst time of first process, then it is I value is 1. So 1 minus 1 is 0 and burst time of I minus 1. 1 minus 1 is 0. So it is taking waiting time of 0, that is p0 process, plus burst time of p0 process. So when we combine these two, then we can get the waiting time of I process, that is the first process, right? So for example, let's consider waiting time of I minus 1, that is 0th process is 0 and burst time would be 27. So what is the waiting time of first process? So it is obviously 27. So this is how we can calculate waiting time of each and every process. So is it possible to calculate waiting time of 0th or the first process? No, it is not possible because the value of I is 0 here, right? So there is no negative processes which is waiting in the queue, right? So we can't calculate the waiting time of first process. So the default waiting time of first process is obviously 0. So next we have turnaround time. So how do we calculate turnaround time? So it is turnaround time of I minus 1 process plus burst time of I. For example, let's say we are calculating the turnaround time of first process. So first, that is I minus 1, that is turnaround time of 0th process and burst time of first process. So it will give you the turnaround time. So later we will calculate the average waiting time and average turnaround time of all the entered process. For example, if the user has entered 3 process, so then we'll calculate average turnaround time of 3 process and average waiting time of 3 processes, right? So next we have actual logic of FCFS scheduling, right? So which will calculate waiting time and turnaround time, right? So here we can see that each process wait until all their previous processes finishes their execution. So we know that FCFS stands for first come first serve. So the process first enters in the queue will be served first irrespective of their burst time, right? So waiting time accumulates with it, right? So next we can calculate turnaround time, as I said, waiting time plus burst time, right? So then it's a then we should display the headings. So with the help of this print statement we are able to display the headings such as the processes, so which defines how many processes we have entered. For example, 3 minutes, so it will display the process starting from P0 to P2, that is P0, P1 and P2. So here it displays the entered burst time by the user. So next it will calculate the waiting time and the turnaround time. So this you will understand when we execute this program, fine. So next it will display the process details. So it will display process PIDs. So here you can see burst time, waiting time and turnaround time will be displayed, whichever been stored in this variables, right? So this is about displaying the process details. So next the calculated average. So the average whichever been calculated using this formula will also be printed using this print statement. After that we are using return 0 in order to show the successful execution of the program, right? So with this even the program will also gonna terminate, right? So this FCFS CPU scheduling algorithm is basically non-preemptive and it is simple, but it may cause convoy effect, right? So I told you, right, in FCFS irrespective of their burst time processes will be served, that is first come first serve. The process first enter in the ready queue will be served first irrespective of its burst time. So what is this convoy effect? So if the process P1, let's say, has the burst time of 50 units and process P2 has the burst time of only 3 units. So the 3 units, which is smaller process, needs to wait until the larger burst time of process P1 completes its execution completely. So which may cause convoy effect. So this is all about the explanation of your program 1. So now let us go to the execution part of this program 1. For the execution part, I am taking the help of online C compilers. So when I run this code, so we'll be able to see this. So when I enter the number of process as 3, right? So we need to enter burst time for each and every process, right? So here I am giving burst time of process 0 as 27, so and process 1 as 3 and burst time of process P1 as 3, and I am giving burst time of process P2 also 3 itself, right? So here I think you are able to see the process burst time and waiting time. So as I said, the waiting time of first process will be 0 because there will be no previous process waiting for their execution. So this is the calculated average waiting time and average turnaround time. So this is all about the explanation of your program 1. Thank you for watching.